All right. You all are welcome to my channel once again. This is KT Physics. Now, we are talking about measurement and units. Now, what is measurement? What is measurement? Now, measurement can be defined as the process of quantifying or determining the size, extent, quantity, or capacity of something. Measurement can be defined as the what? Is the process of quantifying or getting the capacity of something. And when you want to define something, something can be anything. So far, it is what? Physical. It has a physical property. Property. That's a physical property. So in this course of this class, we're going to be looking at measurement. I can give you an example of this. If I ask you, how tall are you? How tall are you? And for me to get that answer, you tell me you are 5 tall. It doesn't make any sense. 5 tall doesn't make any sense. There must be something that will make us to understand that what you are trying to talk about the length. So we can't say that what I'm 5 tall. What is 5 tall? You have to add something to it. 5 inches. 5 inches. So this inches is what we call the units. This inches is what we call the unit. 5 inches. This actually makes us to know that what you are talking about what? The length. So we have different what? Measurements of physical quantities in physics. So we're going to be looking at those measurements as what time goes on. So please, I want you all to what? Stay tuned and follow me to the next class. Now, at this point, we're going to be looking at what? A particular topic, physical quantity. Quantity. Or physical quantities, because it's plural. Now, physical quantities can be defined as the measurement of what? Physical properties. The measurement of physical properties. And this can be subdivided into various types. We have what? 1, fundamental and derived quantities. I'm very sure for SSS 1 student and for those of you that have gone through SSS CE, for SSS 1 student, you will have encountered something like this. This is one of the first topics being introduced to you. So we have what? The what? Vector and scalar quantity. Vector and scalar quantities. I'm going to be giving you a formula for you to identify vector and scalar quantity. We have the last one, dimension / dimensionless quantity. So at the course of this class, we're going to be looking at all these various classification and also coming into what? The conclusion of what? Dimension analysis. All right, we're going to be talking about fundamental and derived quantity. Fundamental / derived quantity. Now, for fundamental quantity, is what we call an independent quantity. These are independent quantity that what? They all stand on their own. They are the basic quantity in physics. They are the basic quantity in physics. They are fundamental quantities. Now, in this case now, we are going to be looking at some fundamental quantities that we have in physics. Permit me to clean this. Fundamental quantity. Now we have the what? The fundamental, or I can also use basic. Basic. We have the basic units, and also we have the what? The basic symbols, or the symbols itself. So now let us look at what we are talking about. Now, for those of you that are always looking forward to shortcut, you can actually have this as what? Something to remember when you are talking about fundamental quantity. Metal. Metal. So at this particular point, it will be what? T square, and L will be what? Square. So this is metal. All right, the first one we have is what? Mass. Please, I want you to keep notes. We have the next one as what? Length. Or you can actually write it in what? The order of this acronym. Metal. We have metal to be what? Mass, electric current, temperature, time, amount of substance, length, and luminous intensity. But I will prefer to write it this way. Time, temperature, amount of substance. What else again? We have what? Electric current. We have what? Because from what we have here, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. The last one will now be what? Luminous intensity. So you can actually buy this if you want to remember. So you have the basic unit to be what? This is kilogram. This one is what? Meters. Please keep notes. We have time to be what? Seconds. We have temperature to be what? Kelvin. We have amount of substance to be what? Mole. From the word molecules. Mole. Electric current? Ampere. And luminous intensity, we have what? Candela. So at this particular point, we're going to be looking at the symbols. What is the symbols? We have what? Kilogram. We have what? Meters. Seconds. Kelvin. MOL. You can put dots. Capital letter A. And what? CD. So these are the what? Fundamental quantities that we have. All right. So now, I want you all to know this. If you have the mass of a body. Now, as an English student, you will understand that I'm talking about the mass. But as a physics and a mathematics student, how can I identify that I'm talking about the mass? I am talking about what? 10. The mass of a body is 10. If I put 10 here, this 10 can mean 10 kilogram, 10 seconds. So for me to identify that one, I'm talking about the measurement of mass. I put what? Kg. If I want to talk about time, I put what? 10 seconds. If I want to talk about length, I put 10 meters. So these are all physical quantities. They call them physical quantities. But these physical quantities are fundamental. And another thing I want you to take home is that what? For you to know it, you don't have to cram. Just have the word metal. This M here stands for mass. E stands for electric current. T stands for time. T also stands for what? Temperature. That's why I put square. A stands for what? Amount of substance. L stands for what? luminous intensity, and another L stand for what? Length. As a mathematician, there is always a shortcut to actually what? Solve problem. So I want you all to meet me in the next class where I actually discuss derived quantity. Thank you.